We're going to do a quick flashback before we do that question. We're going to go back to a previous problem that you saw on your past homework. Maybe you got stuck on this one. This is number 5B. So you could take a quick look at this or maybe you saw the answer but weren't quite sure how to think through it. So I gave you a little thinking prompt there. And maybe you thought, okay, I can find the area of the whole circle, and that's actually a good place to start. But I'm going to propose that we don't even need the whole circle. If you actually just look at the top left corner, I'm going to propose that if we can find the area of the quarter of the circle that we see there, and then we can find the area of the triangle that is not shaded, that triangle is within my other one, this piece. And the difference between those two is this little piece on the outside that looks like, a lot of people call it the crust, which is not a bad description. Together, that red and green make up the entire blue thing that I started with in terms of my quarter circle. So that is the piece that I'm looking for. In geometry textbooks, they call it the segment of the circle. I don't love that name because we've previously defined a segment in this class to be a straight line, a distance between 2 points. And I don't like renaming it as something else, giving something else the same name. But you can use that name. That is what the formal language uses when we look in the geometry textbooks. Okay, but I'm just going to refer to it as the shaded region. So this one wasn't too bad. Let's take a look at how we would find that quarter of a circle. Hopefully you're thinking area of a sector, or maybe you just did area of the whole circle. Pi times radius squared times m over 360 is my formula. Pi times 4 squared times 90 over 360, which you probably just called 1/4, which is great. That gives you 16 pi divided by 4, which is just 4 pi. And then I need to subtract. Let's put a subtraction sign there. And then area of the triangle. So area of a triangle, 1/2 base times height, or base times height divided by 2. Love right triangles, because the base and the height are my legs of my triangle. So if I'm going to find the base and the height, this is 4, and this is also 4. How do I know that? Oh yeah, it's a circle, and therefore the radius is the same, and that's another radius. So I get to use the 4 twice there, 1/2 times 4 times 4, which is 16 divided by 2. So that's 8. And that's going to be my answer. So that segment of the circle, that shaded region, you should have 4 pi minus 8 square units. Okay, now I know I changed questions, so let's go back to the question. Okay, we're going to tackle how to find the area of shaded regions. And in general, I'm going to say that these problems are not new problems, but maybe they're just harder than ones that we've seen in the past. For finding shaded regions. So big idea here is we are going to think subtract. What you see shaded is not a shape that we know a formula for, but maybe it's the difference of two shapes that we know a formula for. So a little more classic would be something like a circle inside of a square, or a square inside of a circle, where we can easily see the two shapes, and hopefully you've worked through a couple that you're staring at now and trying to figure out. Because this one obviously is a little harder, but I think the concept is the exact same. So let's go back to looking at this as, okay, I see a sector of a circle, which in this case is not a quarter of a circle, but you might be recognizing that that's a third of a circle. We'll go through the math in a second. So I'm going to try to find that area, and then I'm going to try to find, gotta change colors this time. The blank section is the triangle, and I want to try to find that triangle because that is right here. And if I can get rid of that, then I'm going to be left with the part that's shaded green in this picture, just that outside crust part. So let's get rid of that there just to clean up my picture, and let's try to do some subtraction here. So area of the sector, if you want to put some words with this, area of the sector minus the area of the triangle is what I'm going for here. So area of the sector, pi r squared times m over 360. In this case, my radius is 14, and my degree measure is, so the only thing I have is 240. 240 it looks like is the rest of the circle, this distance. So I want this one. This arc measure is going to be there for 120 degrees. So I'm going to use 120 degrees. And you might want to simplify that to 1/3. So I'm doing 14 squared, which is 196 pi over 3. I'm going to leave it just like that to keep it in exact form, because if I divide that in the calculator, I'm going to get a decimal. And then I want to subtract. So area of a triangle, I'm always starting with the formula. Area of the triangle, 1/2 times the base times the height. So here's where things get a little bit tricky. I can't just call 14 my base and my height. I do know that this is 14 here. Whoops, iPad didn't like that one. So I know that's 14, but they're not perpendicular to each other. So I'm actually going to turn the triangle. So what I'm going to do is, and I'm going to redraw it over here just so I have enough room. I'm going to turn it so the base is the long side. So my 14 and 14 are right here. And my base actually is unknown right now. So my base is this right here. The other thing that I do know about this, though, and I'm trying to note everything that I do know, is that the angle of the triangle, that was a central angle in my circle, and therefore that's going to be the same measure as the arc measure, which is 120 degrees. Now I kind of put that outside the triangle, and that's because in a second here I'm going to try to find the base and the height. And in order to do that, I'm going to go to right triangles. So I'm going to actually split that up into 2 triangles. So let's divide that. Because it's isosceles, I know that I just divided the base exactly in half. Even better, let's make this a little bit bigger so I can work with it. Even better, I know angles here. So I know that this angle is 60 degrees because I've got 120 divided by 2, so 60 and 60. And therefore this is a 30 degrees, and I know you're so excited right now because you love your special right triangles. So I've got the hypotenuse of my 30, 60, 90 is 14, and I'm trying to find this side, which is across from the 30 degrees. That's the height of my triangle, so that's going to be the short leg. So if I have 14 for the hypotenuse, the short leg is going to be half of that, so my short leg is going to end up being 7. And then I'm trying to find the long leg is going to be this right here. And that's going to be the short leg times radical 3. So that's 7 radical 3. Therefore, the entire base of my triangle is going to be 14 radical 3. Okay, so that's my thinking that I'm going to do. I got to go over here and do area of the triangle. So now that I've got that established, let's go back to our problem that I think we're ready to tackle now. So I've got 1/2 base times height. Base I now established is 14 radical 3. And the height, sorry, it's a multiplication symbol. The height is 7. So your version, I like to keep the radical 3 at the end. 14 times 7 divided by 2, or 1/2 of 14 is 7 times 7 is 49. Okay, you can use your calculator for that, or maybe like the trick that I just did in my head. And it looks like I'm done. I got the area of the sector, the area of the triangle. I can't subtract those because this one has a pi, this one has a radical 3. So to keep it in exact form, I'm just going to call it good right there. We could put some square centimeters at the end to put our units in, and we're done. So hopefully that gives you an idea of how to think through these. It really goes back to triangles and using our relationships. You might have to use trig if it doesn't turn out to be a special right triangle. If you can keep it in exact form and you can use those relationships, then go ahead and do that. There are some that are obviously a little different, so I'm going to have you try those. Do the best you can, sort of try to think as best you can about this idea of subtracting. What's the bigger shape that includes the part you're trying to find, but then maybe some more? And how can you break it into or find shapes that you know how to find the area of? Okay, good luck. Have some fun.